Okay, so what about this one here? This is another bridge. Its arch, in this case, is a rectangular hyperbola. So if I were to draw this arch, it's going to look something like this, a rectangular hyperbola. I'm going to put my center at 0, 0 here, and so that position is going to be negative a, that's going to be 0, negative a, okay? So that would be the position of that vertex. The question says the base is 120 meters wide, so it's going to be 60 here at the base. Okay, and the vertex is 30 high. Oh, we've been told exactly how high the vertex is. So that distance from here to here is 30. Okay, so maybe I just highlight that in red. Okay, so it's going to be 30 meters high, and it's going to be from here to here. Okay, so that's my 30 meters. Okay, and then the 60, just so that maybe looks a little bit nicer too. There's my 60. Okay, it's symmetrical, although my drawing's not quite symmetrical. So it says find the equation. Well, the equation of my hyperbola, since it's rectangular, is fairly straightforward. It's going to be x squared minus y squared equals negative, since I've got my trans y, okay, it's going to be equal to negative a squared. Well, there's really only one thing to solve for. It's just a. So find the equation. I need to find a, I need to plug a coordinate into the graph. Now, if I plug this one in here, that's no good because I don't even know what a is. If I knew that, I'd be able to solve this. I don't need to solve anything. There's no other coordinates here other than this one here. Okay, we know the x coordinate is 60. The problem is, what is the y coordinate? Well, if you take a look at the positioning, here's my x-axis here. I'm going to go down a and down 30 more. Well, I do know my positioning. That position is going to be negative a minus 30. Okay, so that's going to be that vertical position. Here's from here to here is my a minus a, and this represents my minus 30. Okay, I have my point. I have a variable in this coordinate, which seems to be a problem, but notice it's the same variable that's already in here. So it's not like I'm introducing a new variable. So I can use that principle that every coordinate xy must fit the xy graph. So if I plug 60 in for x and negative a minus 30 squared for y, let's see what happens. I get 3600 minus a squared minus, so it's going to be negative times negative, so it's going to be plus 30 or plus 60a. Negative times negative is going to give me plus 900. That's equal to negative a squared. Well, if you look at the algebra here, those a squareds are going to cancel out. So I end up with 3600 minus 900 minus a squared minus 60a is equal to negative a squared. Those a squareds are gone. This is not even a quadratic equation. It's actually a linear equation that I need to solve for. So this linear equation is going to be 2700 is equal to negative, it's going to add 60 to both sides because I need that 60a on the other side. Divide by 60, divide by 60. The only thing I need to solve for in this problem was a. And so 2700 divided by 60 is going to be equal to 45. Okay, so the a value is 45. So that means then this length here is 45. And not only that, my equation is going to be x squared minus y squared equals negative 45 all squared. Okay, so there's the equation of my hyperbola. This question also asks a part B. So this is part A. There's my equation of my hyperbola.